Well, thank you all very much for having me here. I'm super excited. This is my first time to Israel, and yeah. I want to start by talking about this particular quote because this quote has been around for a long time. If you don't know who Alan Kay is, by the way, you should Google him and look up the Wikipedia, one of the grandfathers of what we do in computing science. This quote is often thrown around to suggest that it is that we can dream big and we can make whatever the future that we want to be. And so people aspire to go create all these amazing things. We can say, oh, well, we can just invent whatever we can dream up, we can invent. And we can create that future. But I see something different in this quote, and it's the thing that I want you to keep in the back of your mind as I talk through today. I see something different in this quote because what I see is a responsibility. What I see is that the future that we are going to have, the future that is going to happen a year from now, 5 years from now, 10 years from now, 50 years from now, is directly our responsibility. The things that we are doing, the choices that we're making now are going to directly impact that future. And that means that if we are going to participate in this thing called building the web, we should be very careful about those decisions to make sure that we don't create the kind of future for ourselves and for our kids and our grandkids. We don't want to create that future if that's not the future that we want them to have. There is a responsibility. We need to be asking ourselves, what direction are we actually headed in? Because there's an awful lot of different futures that are possible. And not all things that we could get to, not all things that we could do are things that we ought to do. So I want you to keep that in the back of your mind as I begin to ask some of these questions this morning. I'm going to start with a brief history lesson, but it's going to be a little bit strange because it's not what you're expecting. This is a brief and incomplete history lesson of American spaceflight. And credit goes to a NASA engineer, David Hassan. He came and spoke at my son's elementary school, and I took some of the ideas that he had from his talk to frame the beginning of my talk today. So if you're not familiar with the history of American spaceflight, it was roughly divided into three basic phases over the course of the 1960s. Over the course of that decade, it's divided into three phases. It started with the Mercury Phase, and these were using the Atlas rockets. And if you look here on the left, at the very, very top where that tiny red thing up there at the top is, that's where the astronaut, one astronaut, singular, was actually bolted in. Not like we see in the movies where they can move around and dance in space and all of that sort of stuff. Literally bolted into his chair and they welded the door shut. That's what it was like in the earliest version of us sending a person into space. So the Mercury program was all about, can we get somebody into space and get them back here to Earth, and they survive that trip. That was essentially the big idea. We laid out this vision that we want to put somebody on the moon, but there's a whole lot of steps that are going to be involved to get us there. So what are those steps going to look like? What steps do we need to do? So they divided, the first mission was just, can we successfully put people into space? But what was interesting, and this is, again, something that I hadn't realized until David pointed this out, what was interesting is that even during this particular phase of spaceflight, even though they were really just focused on this one goal, can we get a person into space, they were also already thinking about what they were going to need in the next phase. So they had an eye both to the immediate future as well as to where they were headed. And that's a really important takeaway. There is a tension between, are we focused on just the immediate, just shipping something, or are we also focused, or at least thinking about strategically, where are we headed? Because in the second phase of the space missions, which was called the Gemini Phase, they realized something during the initial phase that was a really big problem. And that was, we can't have the person bolted in. That's a really terrible idea. This is super dangerous. This is never going to work. And also, by the way, in the first phase, they didn't really want them to participate. We didn't think that we could trust humans to do something like flying a rocket. And so they were basically just along for the ride. The computer did everything for them, and they said, no, that's a terrible idea. We actually need to have them be an active part of the mission. So in the Gemini stages of these rockets, again using a different rocket this time, the Titan rockets, what they needed to do was have the astronaut, now there were 2 astronauts, not just one, and they needed to actually participate in the mission. So there were buttons and controls that they actually had to work with during the flight, and they could move around to an extent within it. And they realized all of these things from both successes and failures they had in the first phase. But in this particular phase of flight, in the Gemini phase of the space missions, their goal was, can we go outside of the rocket? Can we do spacewalks? And can we dock rockets together? So we made some big progress from just, can we get a man into space, to now can we start doing something useful while we're in space? And they were already doing experiments during this phase that would lead them to the third and final and most famous of the phases, which was the Apollo phases of the space mission. These are the ones that you've most likely heard of. It's the ones they made movies about, like, for example, Apollo 11, when Neil Armstrong was the first man to set foot onto the moon. So this Apollo phase was, of course, the finalization. Let's finally take that literal last step and actually get onto the moon. But there were a bunch of things they needed in this phase that they would not have been able to achieve here had they not been thinking about that back during the Mercury and Gemini phases. And again, it is that idea about these small steps that have to be made, but also a thought towards the bigger strategic direction. We have to know that we're headed towards setting foot on the moon so that we're doing the right things now, the right preparation steps and the right experiments, figuring things out. They had to invent all of this from scratch. There was no manual. There was no book that told them this is how to get to the moon. And so they couldn't have all of it planned out. But if they didn't have that strategic vision, I don't think we would have achieved this goal that we set out to do this in just 9 or 10 short years. And so what he points out is that from that first primitive rocket to being able to set someone on the moon, we made a lot of progress, but we didn't make giant leaps. Rather, we made lots of baby steps. That we took lots of tiny little baby steps. We made one decision and we did one experiment and we made one progress, and then we did a different mission and we did another thing. And this is a lot like software development. That you have to have this bigger vision, but you also have to take small incremental steps. And the problem that I see a lot in our industry is that it gets far too easy to get myopically focused only on the tiny steps, only on what is immediately in front of us, and lose track of that bigger vision. Where are we headed? We call this Agile, by the way. Agile means I don't need to worry about where we're headed. We only need to worry about what ships right now. We've codified it into a whole discipline and practice. So I want you to keep that tension in mind. I want you to be thinking not only about the baby steps, but about the big vision of where are we headed? Are we trying to set foot onto the moon? Now, some of you, I'm sure, at least most of you, have heard Brendan Eich's famous always bet on JavaScript. And he did this slide at a conference back in, I think, 2010 or 2011, I think at a JS Conf. He unveiled this slide and he said, you know, over the years, everybody has claimed that JavaScript was going to reach its final limitation and not be able to achieve something that it was aspiring to do. And so we're going to eventually, JavaScript's going to outlive its usefulness and be replaced by something else. And there have been naysayers that have said that over the years, and they first said that JavaScript couldn't do the rich internet apps the way regular native apps were, and then they said it couldn't be fast, and they said it couldn't be fixed and correct, and they said it couldn't do multi-core. And it turns out that every time that people have bet against JavaScript, they've been wrong. That JavaScript has had this amazing flexibility to it to begin to grow and evolve. And if you think about where Brendan Eich created JavaScript, it was in this 10-day prototyping phase. It was an experiment. And yet today, JavaScript is the most ubiquitous language on the planet. It's in robots and refrigerators and TVs and watches and glasses and light bulbs and every other kind of device that you can imagine. And there's no possible way that somebody could have imagined that exact future, nor could they have imagined and planned out all of the tiny baby steps that it would take to get there. And so there is, I think, to some extent, some accidental genius involved. That we have a language that has been so flexible and has been able to be stretched in all of these various different directions. And so it is rightly said that if you've been betting against JavaScript, it's been a bad bet. By the way, if you're not familiar with the reference, why this is always bet on, this is Wesley Snipes in a movie called Passenger 51, and he famously in this movie, he says, always bet on black. So that's where this comes from. Always bet on JavaScript. Don't bet against JavaScript. Okay, so that's true. We always want to bet on JavaScript. And the talk today that I'm giving you is called Keep Betting on JavaScript. So it is a hopeful, forward-looking message that says, yes, we should keep betting on JavaScript, but it comes with the caveat that we have to ask ourselves, what is that future JavaScript that we're betting on? Up until this point, I would argue that it has been a rather safe bet. It has been a rather safe bet that if we just keep betting on it progressing according to the needs of the industry, that things are going to go okay. But I think we have reached potentially an inflection point where if we're not careful, the future that we are building is not necessarily the future that we want. So we have to keep betting on JavaScript, but we have to know where that is headed. I want to talk about another history lesson. Again, this one is perhaps not exactly what you were expecting. I want to talk about my journey into web programming and into JavaScript. Bruce shared just a moment ago how he started in 2002. I started somewhere around that time, about 1999 to 2001, somewhere in that range is when I was getting into the web. So I want to talk to you about my journey into JavaScript. As a matter of fact, the first experience that I had with anything related to the web was in 1997-ish in high school, and we had one computer in the high school that was connected to the internet. And it had like Netscape 2 or Netscape 3 on it. These were the days of Netscape 3 and IE4, and these were very primitive days, very early days of the web. And I remember reading the like 4 websites that were in existence at that time. We would go and surf, not for any particular reason, but just because this was the cool new thing you could do. You got 30 minutes a week to go sit at this computer and experience what would be the web. And I wish at that moment that I could have seen what my career trajectory might be, that I would end up making this a profession, going into figuring out how to do the web. I couldn't even conceive at the time that somebody could figure out how to build that sort of stuff. It just existed, and I didn't even have a mindset to ask, how does it exist? How does one create this? And I didn't develop that curiosity until a couple of years later when I was in college and I was able to build a website for one of the student organizations that I was part of. So that's where my journey started. Was I saw the web, and then a couple of years later became curious about, well, how can I do something like that? How can I build something like the web? And of course, the way I answered that question is the way most people answered that question. I did view source. I clicked on view source to figure out how they did it, and then I copied it for myself. And it was amazing because the most important thing that you could put on the web was a trailing mouse cursor. So I wanted to figure out how they did that, and I would copy and paste those. I can't leave this up here. It's going to distract a lot of you, so I'll move on quickly. But I started building websites. Now, I went back and found one of the original sites that I built. This is like 2000-ish that I built the first website. I went and found this on Web Page Archive, and I want to show you just how terrible some of the earliest JavaScript that I wrote in 2000 was. I'm super embarrassed to admit. I have no idea why I was putting those extra parentheses around those Boolean variables. I don't know what I was thinking back at the time, but I found this code and I was like, oh, this is going to be fun to show the whole world all the mistakes that I made. But you can notice here that I was doing all kinds of like fancy creating divs and layers and dynamic stuff. This was for a website where it was my uncle. He had a home building website, and he wanted to show off the homes that he had available for sale. He was a home builder, and he wanted to show off the homes he had available for sale. And I was doing totally unnecessary. It could have been a totally dynamic, a totally static website. But, you know, I'm learning JavaScript, so I want to do everything dynamic. This was like the earliest version of what we might call like a single page application, where it would just switch in different pages when you clicked on stuff. And then around that same period of time, this is a different website. I built a portfolio website for an artist. She did paintings and drawings. And I was really embarrassed to see that I was using eval in this particular website. But then I realized, actually, I was doing some research, and I realized why I needed to do eval, and I thought this might be an interesting point. You'll notice above it that I've got these image 1 through image 9 arrays. At this point in JavaScript's history, it did not support multi-dimensional arrays. And I needed a multi-dimensional array. So you know how I did it, was I had 9 or 10 separate JavaScript arrays, and then I evaled with the index number to get to one specific array to have the second dimension array. I don't know how I came up with that, but somehow I was just hacking my way to some solution. And thankfully now, obviously, JavaScript does support multi-dimensional arrays. But these were some of my earliest baby steps into what would become a profession for me, building the web and writing JavaScript to build the web. I moved on a few years later in my career. I graduate from college and I have a career and I'm working at an agency, and I got the opportunity to build the homepage for this regional airline in the US called Southwest Airlines. It's the first time they'd ever hired anybody to do their own website, and I was the lead front-end engineer on this project, one of many high-profile projects. So I'd really sort of arrived in my career like I'm building stuff that millions of people are going to get to see. We were given this project. The designers had built, designed everything, spec'd it out. We were given this project 3 weeks before the Christmas break and told me and 3 other engineers we had to build this whole homepage in 3 weeks. And you'll notice at the time, this was like 2006-ish, like late 2006, I think. And so if you notice in this, we've got things like a calendar widget. We used the YUI calendar widget. This was brand new, state-of-the-art. There were JavaScript frameworks that could give us widgets. And a designer dropped this into the design, and then we had to figure it out. I remember we spent quite a while, like several days, just trying to hack through the code on this YUI calendar widget to get it to display the full month name instead of the abbreviated month name or something ridiculous like that. We didn't know what we were doing, but we're hacking through all this code trying to make it work. And 2 weeks into that 3-week period, we're almost ready to get this thing wrapped up and go on Christmas break. And they said, oh, by the way, this website needs to support Netscape 4. And we're like, what? There's no way we're going to make this YUI calendar widget work on an old browser like that. We did all kinds of hacky stuff like conditional comments and hiding things, and we didn't get much of a Christmas break that year, that's for sure. So I was definitely working on the real web as we might think of it today. I was using JavaScript frameworks and components and things just like you would do today. And I did just like many developers did. I just dropped this stuff in. I copied and pasted it off of some tutorial or some documentation page and dropped it in and then hacked my way to it. I didn't really know at this point what I was doing, but I was somehow able to ship a website that millions of people were using. For a brief period of time, about a year, we outgrew the capabilities of the web, and this agency had me build websites in Flash. And one of the websites that I spent quite a bit of time on was this kids website for a grocery store chain in my part of the US called HEB, and this was the HE Buddy kids website. Built a bunch of games and other stuff like that. This entire website is built in Flash, and I literally cannot even load this same website onto my computer because I have Flash completely banned on the computer. So I had to load up like an old VM just to get this screenshot, because the site is still there. 13 years later, it still says, new site, new game. They never touched it after I built it and deployed it. If you still have Flash, you can go check out HE Buddy. But I was kind of cheating. Sort of cheating, because yes, this was still web programming, but we couldn't really do consistently cross-browser at that moment in 2007, 2008. We couldn't really do consistently cross-browser the things that the designers were coming up with. So Flash was kind of this pressure release. It was a cheat that allowed us to have this kind of consistent canvas to paint things onto. So I spent a bit of time working in Flash. Now I'm saying cheat kind of with some air quotes, because this was actually still technically web programming. This is an important part of the web's history, is that we did Flash, and actually most of what we have in HTML5 and even JavaScript is as a direct result of things like Flash. They invented ideas that we're still trying to catch up to with the open web platform. So I'm not at all hating on Flash, but it's certainly not something I do anymore these days. But for a brief period of time, this was a very important part of my journey into figuring out how to build and deploy to the web as a platform. And then you fast forward about another year, well into 2008 at this point, and my career had really become all about the dollar signs. But of course, I'm talking about jQuery. Like everybody else, at the time, jQuery just took the web by storm. And I was fascinated by jQuery, and this is actually an important inflection point for me, because this was really the first time that it sparked a curiosity in me. I, at this point, had really just been using things that people had provided to me and not really curious about how or why they work. And for the first time, I saw something like jQuery, and I'm embarrassed to admit, in 2008, I'd been doing it for almost a decade, and I literally did not know that the $sign was a valid character to show up in a variable in JavaScript. I was like, what is this magical $sign thing? And I had to go look it up, and I was like, oh, that's just a variable like X or A. But I dug into the jQuery source code, and I was tremendously curious about how they did all this stuff with the this keyword and closures. And what opened up for me at that moment was a curiosity about JavaScript, the language. This was not JavaScript, a toy anymore. This was JavaScript, a real language that could solve real problems. And for some reason, what changed in me was I thought to myself, if this is where my career is headed, and I made these early bets on the web and on JavaScript, if this is where my career is headed, maybe I ought to take it more seriously. Maybe I ought to really understand how this stuff works instead of just dropping in components and widgets that I've copied and pasted from other websites. So I pored over that source code and tried to understand it and build my own tools to do so. And it was around the same period of time that I started working in open source. And the very first open source project I did, again, sort of bridging from JavaScript, bridging from my Flash days back into JavaScript, is I built this thing called Flexor. Flexor was a cross-domain Ajax polyfill, if you will, to replace XHR. To do cross-domain Ajax, at the time when we didn't have cores, we couldn't do cross-domain Ajax. I needed this for a thing at work, and I built it, and the way it worked was it used an invisible Flash file, because Flash had this ability to do cross-domain requests in a permissioned way that the web didn't have at the time. So I have this JavaScript API that looks like XHR, and it bootstraps this invisible Flash and does cross-domain, and I released it as source code. This is pre-GitHub. I just released it, I think, SourceForge or something, but this was my first open source. Hey, I've learned something about JavaScript, and I now understand how to use closures and build things. And shortly after this, in 2009, my next open source project that I'm probably most well known for was Lab.js, dynamic script loader for performance optimization of websites. And this is actually what got me started in conference speaking, was that I got invited to speak about this particular project. It was in use by a number of big sites, including eventually sites like Twitter. And so I got to start talking about this stuff, and you'll see that I've made some progress in my JavaScripting at this point. A little bit more sophisticated than what I was doing a decade earlier. But I still didn't fully understand JavaScript at the time. And I wanted to take it seriously. And at the time, there was this great divide in what was available for resources. There's obviously lots of websites out there that you can learn things from, but if you start talking about trying to really learn JavaScript, take it seriously, try to understand what books do we have available. This image has been passed around forever as sort of a joke about JavaScript. Because on one side we have JavaScript, the definitive guide, and on the other side we have JavaScript, the good parts. And because there's a big disparity in the size, that must mean JavaScript has a bunch of bad parts. That's the joke, right? And so a lot of people have laughed about this particular idea about this big gap. But for me, almost immediately what occurred to me was this is like the gap between trying to learn about some topic by reading an exhaustive set of encyclopedias versus trying to learn about the same topic by reading the Cliff's Notes. In other words, you have one extreme where you have way too much information and it's almost too much for any one person to try to get in their head. And on the other end of the extreme, you have very brief summaries of information that might get you passing a test if you're crunching for a test. But certainly you would not be able to say that you have any sort of mastery over the material by simply reading the Cliff's Notes. And what I see here and what pains me is this giant gap between these two. If I want to understand this stuff and there's nothing there in the middle for me to learn from, and if it's not there for me, then it's not there for the rest of us as well. And this is what led me, this is one of the problems that I pored over, and it's what led me to decide to finally write the You Don't Know JS book series, something I'm fairly well known for now. The You Don't Know JS book series started out being 3 books, 50 pages apiece. That was my pitch to O'Reilly. I'll write 3 quick 50-page books and then we'll be done. It turned out they were 6 books with 1,100 pages. Because it turns out there's a whole lot more to say about JavaScript than I even understood at the time. And And if there is no other way for me to describe what this book series is, it is my documentation of my journey asking all of the questions, what is JavaScript about? How does it work? Why does it work? And I documented that in book form so that other people don't have to go figure that stuff out for themselves. So I sort of fixed the gap, if you will. I created what was missing in between. Hopefully a relatable discussion about all of the different parts of JavaScript, not presented in an encyclopedic format that doesn't work for most people, but presented in a conversational tone. It's almost as if you're just sitting down and saying, hey, why does that thing do that? Here's why it does that, and here's how you can use that. That's been my goal, and that launched my teaching career. And I now teach full-time, so I travel all over the world. I've now spoken, this is my 21st country in 6 continents. And I was about to hit my 7th continent. There's literally going to be a conference in Antarctica in January of next year. And I was accepted as a speaker, and I was going to go and get my 7th continent badge. Unfortunately, I had a personal conflict. I can't make it. But I'm going to get that one day. I'm going to get that 7th continent for sure. But I'm tremendously privileged to see such a broad range of our community from speaking and from teaching. So my journey has been similar to the one with NASA. It's been marked by lots of tiny baby steps. I couldn't have planned out my journey exactly the way that I wanted, and I wouldn't have been able to even dream of where I am now if I had been trying to plan to that. So I really just sort of stumbled through all of these baby steps. So one more history lesson. And this is of the JavaScript language, but it is certainly not a complete history lesson of the JavaScript language. The early days of JavaScript. This is some of the earliest code that we know that we have. It still runs today. There's a website that was built in late 1995, very shortly after JavaScript was a thing. And this code was written and deployed to the web, and it's still there. You can go back and find code like this in Web Page Archive. This was some of the earliest JavaScript that was ever deployed publicly on the web. And it's interesting to me because it's actually more sophisticated than I would have expected for code that was basically 10-day prototype experimental language code. There's some sophistication here that I wouldn't have even expected at that time. And then we started to formulate more formal JavaScript specification. There were some JavaScript specifications, version 1 and version 2 sort of fell on top of each other. But we started to get some very interesting additions to the language very early on. This is like 97, 98 time frame. We started to get some JavaScript things that we know today. Like, for example, you started to be able to assign to the prototype of a function and do the very earliest forms of what we would eventually call the prototypal class pattern in JavaScript. And then in ES3, we got some huge things. Most importantly, in ES3, we got the ability to actually use functions as expressions. We got closure in JavaScript, and I would argue that was the biggest inflection point in the history of the language because it became truly a first-class programming language at that moment. We also got a bunch of other things like try catches and exceptions and things like that. So there was a ton of things that finally formalized in ES3. Now, after ES3, because ES3 was in 1999, after ES3, there was a set of proposed changes to the language that were quite radical. And they went by this name ES4. And we're in like 2003, 2004 time frame at this point. And there's a set of people that are in the working group in TC39 that want to do this, a whole bunch of changes. They want to add classes and packages and types and all kinds of stuff to JavaScript, and they have this proposal together with ES4. And then there's another faction of people that were very vehemently opposed to that direction for JavaScript. And they could not agree, and they fought back and forth for months and years, and they couldn't agree. And eventually, one of the things that they did to try to prove this was they went and implemented that. One of the groups that was in favor of ES4 went and implemented, and that's what ActionScript 3 was an implementation of this ill-fated ES4 specification. So if you've ever written ActionScript 3, you actually wrote ES4. That was JavaScript, or at least what they wanted JavaScript to be. Unfortunately, this was not to be. They could never agree, and after a prolonged period of fighting, they eventually gave up and said, this isn't going to work. We're not going to be able to come to an agreement here. And we entered into what we would disaffectionately now refer to as the dark ages of the web, because around this same period of time, 2005 and 2006, is when also the web platform began to stagnate. Not only was JavaScript not able to progress, but the greater web platform was stagnating. And famously, folks at Microsoft said, well, there's not going to need to be any more Internet Explorer, and they disbanded most of the Internet Explorer team, and they said, we don't need any new browsers. We don't need it. There's something that's going to replace the web. And it came within that close of the web dying at that time. There was a long period of time where nothing progressed. And we arguably saw this flourishing of all these other things like Flash and Java and things like that because the web had no answer for what people wanted to do on that web delivery platform. In this same period of time that JavaScript was stagnating with ES4, there was another proposal. A lot of people think it was the same. It was actually a separate proposal called E4X, which was basically XML for JavaScript. And this might look a lot familiar to you because the revenge is that even though E4X eventually died, we got it back in the form of JSX, right? Because people have really wanted to embed things like HTML in their JavaScript. So this one died, and I would argue it died a very well-deserved, justified death of dysentery. I'm glad that JavaScript did not pick up this particular form of spec. All right, so finally they came back together. This is a full 10 years later. We went from 1999 all the way to 2009 before they finally came back together and they said, all that big stuff that we wanted to do and couldn't agree on, let's come up with a very small subset of changes. And the most notable of those changes was strict mode. We really needed strict mode. Let's go ahead and land ES5 with a few extra APIs and basically strict mode. And that was the compromise in 2009 to get JavaScript back on a track of evolving after stagnating for an entire decade. Also, over that same period of time, we've now got the browser wars that are raging, and that's really good and healthy for the web because we have Chrome and Firefox and Internet Explorer and Safari, and they're all fighting against each other, but for our benefit, they're all trying to progress the web faster and progress the web with more features and things like that. And then we went, unfortunately, another 5 years, 2015, before we could land something like the next version of JavaScript, which was known as ES6. This was another huge change that in many ways it was basically the revenge of ES4. It was all the stuff that we really wanted in ES4 back in 2004. We had to wait more than a decade to land it in 2015. All of these changes. And many of you have probably felt still today, even 3 or 4 years later, the fatigue of all of those changes landing all at once. And this is sort of the anti-story of lots of tiny baby steps, because when you have process breakdown and then things have built up and they've built up and they've built up and then you just throw it all on people like throwing up all over them. And people don't know what to do with it. And we still have problems today in JavaScript because people are still trying to come to terms with what all these things do. It's great job security for somebody like me who teaches JavaScript, but it's not healthy for the web for us to be building up all of this stuff and making no progress and then all of a sudden having this huge change set. So in this time, they decided at this moment, this was the last time that JavaScript would build up a whole bunch of changes for years and years and then just dump it on the community. Instead, they decided to move to a year-based revisioning system. They tried to rename ES6 to ES 2015. They tried to tell people, stop calling it ES6. I'm here to tell you, as somebody who had written a book already at that point and published it with the word ES6 in the title, it's not called ES 2015. I don't care what they say. It's called ES6. Okay? So stop calling it ES 2015, it's called ES6. But after that, then we started getting yearly updates, and these were much smaller and much more self-contained. In ES 2016, we literally landed just 2 tiny features. We landed the star operator for exponentiation, because we always do that. And then we added array includes, which is actually one of my favorite features. By the way, starting with ES 2016, stop calling it stupid stuff like ES7. It's not called ES7 anymore. It's called ES 2016. Okay? I still see people today writing blog posts saying ES7. I'm like, get with the times. So ES 2017 came along the next year, and it's not ES8, it's ES 2017. And we landed one of the most favorite features in all of JavaScript, which is the async await function. And a whole bunch of other things as well, but we landed async await in ES 2017. Last year in ES 2018, we landed async generators, which is like the love child between async functions and ES6 generators, put them together into one function, and now we have async generators. Sounds weird, but there's actually a very important use case for that. And again, there's a bunch of other little things that landed, but that was kind of one of the major hallmark features. And just a month or 2 ago, they voted on the final feature set for ES 2019. And I've got a piece of code here. We added some little features like object.from entries, which nobody's going to use. But the big one was we finally resolved Smushgate. right? It's not called smush. It's called array.flat, and then we also have .flatmount. So that's the big one. And also just a tiny little one, which is actually one of my favorite features in all of JavaScript history. On line 21, you see I have a catch clause, and I don't need an error variable, so there's no catch definition there. So we finally landed that. I've been wanting for that for years, and now we don't need to do those, have our lynchers complaining about unnecessary error variables. So it's this repetitive thing that you keep hearing from me, that JavaScript is now back on track to start making lots of tiny baby steps. And any time that it got off track from making those baby steps, anytime the progress wasn't incremental, it was bad for the web and it was bad for JavaScript. And the best progress has always been the progress that was incremental. This is a good and healthy thing. And it makes me wonder then, well, what is the future going to be? If we've now caught ourselves up, is the future going to continue to be like this? And are we going to continue to have the same kind of future that we want? So where are we going to be placing those bets? Well, here are some bets that were made that I would arguably say have been very bad bets along the way. Things that basically said we don't need an open web platform. What we need is a future for the web that is this closed proprietary system. And I'm going to make a really controversial statement and say, I'm going to predict that within the next couple of years, we're going to say that this was the worst bet of all. The native app store, the worst bet of all against the web. Steve Jobs came out originally launching the iPhone and said the web is the future, and then the very next year he said, no, I can't make money on the web, so the native app store is the future, because that's where I can make money. And that turns out, I think, going to be a really bad bet. Because what we have is better bets that have been made since then, like the open web platform. We have JavaScript and HTML5 and CS3. And when you put those three together, you get the best bet of all, which is progressive web apps. A quick note on progressive web apps, by the way. One of the best parts about progressive web apps is that they're solving finally something the web platform itself hasn't been able to do, which is that I can be reading something on my phone and get on a plane and that web content is still there. The offline ability of the web is a critical feature. And I'm going to make a claim that might surprise you, but I'm going to say every single website in existence, I don't care what it does, every single website needs to have at a minimum a caching first service worker so that it's offline capable. Because I should not be reading your blog post and then I get on a plane to fly over here to Israel and all of a sudden I can't read your blog posts anymore. That is ridiculous, and it is against what the DNA of the web should be about. So progressive web apps and the technologies underneath that umbrella are giving us a future that is going to be much better. Much better for the web and much better for this sort of collaborative work that we do together. One of the other things about progressive web apps is that we're getting away from this idea of disability, talking about what people can't do, and instead talking about what people can do, about their abilities rather than their disabilities. And I would argue that this is one of the ways that we are going to win against the native app ecosystem, because the web has always had in its DNA to be accessible first, and we've been the ones that have been screwing it up. But we have the opportunity to change course. We have the opportunity to make better decisions. And these technologies are going to write a different sort of a future, one that embraces what people can do rather than restricting them based on what they cannot do. And finally, I think what the web has is we have always had the ability to embrace the idea of incremental updates. I have a game on my phone that I love playing. Every time it updates, about once every couple of weeks, it's a 119 megabyte download. Which is not such a big deal when I'm at home and I've got my super fast Wi-Fi in the US. But when I'm here abroad, which I spend most of my time traveling abroad, I get 2G internet speeds. Guess how long it takes me to download 119 megabytes over 2G speeds? I'm still waiting on the download from my previous trip. That's how long it takes. These are all fantastic things for the future, and I think they represent great bets for the future of the web. Think about something like the International Space Station. It was famously this amazing collaboration between the United States and Russia and several other countries. They came together. Think about what that first meeting was like. They don't even use the same system of measurement. We've got the imperial and the metric system. How did those scientists get together and figure out that this thing fits together with this thing? It's an amazing story of open collaboration. And I will tell you that open collaboration is the thing that has always won. You have to start open. You can't build something in isolation and proprietary and then just sort of whitewash it as open. It has to start open. That's the only way that it's ever worked. And that's always been the best bet throughout all of history, not just technology. The open path is the one that's always eventually won. But here we come to the question point for the rest of my time with you, and I know my time is short, but we come to this question point because JavaScript really is at a fork. Just like in the proprietary versus governmental-based space technologies, and there's a fork happening, and we're not really sure, and I'm not making a political statement on which one is right or wrong, but it is undeniable that there is a different future that's going to happen now as they begin to fork, and I'm going to say that there's a different future that's going to begin to happen as JavaScript, the language, begins to diverge more from JavaScript that is a machine. These two have been the same for a long period of time, but they're beginning to diverge, and Brendan Eich is just sort of peeking around the corner saying, what's going on with my JavaScript language? It's just like if you had two spaceships that took off from Earth, and they were headed to these distant galaxies. For the first several million years, they would look like they are flying in parallel. They look like they're flying towards the same destination, but eventually, they end up millions of light years apart. And the problem that we have is when we think about these two things on this same path and we only think myopically about what's happening right now, we can't see that they're on slightly different paths, that millions of light years from now, they're going to be in entirely different locations. For a long time, JavaScript has been the same. It's been able to serve all of these different things, that both the language concerns and the machine concerns. But I'm arguing that we're going to be heading to very different galaxies, and that might not be the web that we want. So the future of what the web is has always been incremental and open, but will that always be the right way for the web to evolve? Or do we need to have a different approach? So very quickly, I want to talk to you about the language versus the machine of JavaScript. These are a couple of things that we know about JavaScript, the language. First of all, code is a form of human communication, and you can read that because your brain understands English and can understand communication. Code is first and foremost a means of communication. It's not instructing the computer. And I actually think that JavaScript is one of the best suited languages in all of existence for you to communicate your ideas. It's called the lingua franca of the web. And by the way, if you don't know what that means, you should look it up. Lingua franca doesn't just mean everywhere and, ubiquitous. Lingua franca means it's an important bridge language between two incompatible languages. And JavaScript is where a Go programmer and a Haskell programmer that speak very different ways of thinking can somehow figure out a common way to communicate with each other. That's an important part of JavaScript. One of the most important parts of JavaScript is that it was built from the beginning to be multi-paradigm. Not just that you could pick one or the other, but that you can pick all different paradigms within the same application. I would argue that's one of the reasons why JavaScript has become so popular and stayed so popular, is because it has been so flexible. And JavaScript has also been declarative. And it is moving more and more in the direction of declarative. As a matter of fact, most of what ES6 did was to move from the imperative forms of programming more towards the direction of declarative programming. And that favors more readability and more understandability and more maintainability for our code. This is a good thing, and it's going to continue to happen for the future. It's a sign of maturity of the language. Also JavaScript, and really the bigger web, but definitely JavaScript, says code that was written back in 1995 still runs today in the web. And that's a good thing, because you can bet on JavaScript and you can write something and know that next week it's not just going to break because some browser decided they don't like that JavaScript. There was a time when people thought that JavaScript was slow and sloppy and buggy and inconsistent. And some of you may still adhere to some of those old thoughts about the way things were back in like 2004. Please join us in 2019. That's not what JavaScript is today. That's not the status quo of the web. We have a fantastically consistent and mature and constantly evolving ecosystem of technologies. And the language is serving us in many great ways. Here's a couple of quick things that are coming down the pike, likely, hopefully, probably going to show up in JavaScript near you. If you're into class programming, we're getting a whole bunch of new features added to the language that are going to allow you to communicate better with your code. Things like class fields and private methods. Those are on the cusp of landing. They almost made it in. They'll probably make it in next year's standard. We have optional chaining. In other words, instead of having to check to see if a property has been undefined before you access a property on it, now we can use the question mark dot operator to just access it and fail safe back to null. Readable numbers, a tiny feature, but one of the things that I think will actually help a lot of readability, the ability to put separators in your long number literals, like the underscore character to separate out the digits. And bigint, maybe one of the biggest complaints about JavaScript is that it has this one single number type that's not able to handle many of the important use cases that have emerged on the web, and we're finally starting to evolve in a direction of 64-bit numbers. We now have bigint support. That's at stage 3 and almost about to land in JavaScript. It's already in several of your browsers. So bigint represents the fact that JavaScript is maturing in all of the ways that people have needed it to mature. It is responding to those needs. So stop thinking the way you used to think about JavaScript, that it's this weird and inconsistent and behind sort of system. It's on the cutting edge and it's moving forward and evolving. So if you think about how JavaScript has evolved, we're not just landing on the moon, we're talking about landing on Mars. There's a bright future with lots of steps ahead of us. We've made a lot of progress already and we've got a long way to go. I'm not betting against the future of JavaScript. I'm not worried at all that JavaScript's going to be around 20, 30 years from now. I'm perfectly secure in knowing that I have good job security. Investment in JavaScript is going to continue to pay off for any of the lifetime that I need to worry about my career. It has a bright and vibrant future. But it might be a little bit different than some of us are expecting, because there is this other direction, this other tension that is pulling JavaScript in this other direction. And for a while it was just doing it within the constraints of JavaScript, but now it's starting to break out of JavaScript. And that is what has me concerned. We have the machine side of JavaScript. For many people have said for many years that JavaScript is the assembly of the language. I've always balked at that. I don't think that that's the right way to think about JavaScript, as if JavaScript is, it doesn't even matter what it is. It might as well just be ones and zeros, because we're all going to write in our other favorite languages. The DNA of the web is inextricably linked to what JavaScript is, what it has been, and what it will be. To forget about JavaScript, the language, and say it's only just some target for compilation from other languages is to forget an entire important part of the DNA of the web. So I don't like thinking about it as the assembly. But there are certainly some very important concerns. There's increased demands that have been asked for JavaScript. We want 3D gaming, and we want all of these sorts of things that the language itself really wasn't capable of doing. And so we started adding these features to JavaScript to support that use case that really don't even make sense. I mean, I'll show you, like, for example, Proxy. We added the Proxy feature to JavaScript back in ES6. And while it's a great and interesting feature, none of you will ever author a proxy. Nobody's ever going to write that code. That's going to be code that is written for you by a machine. A compiler is going to write proxies for you. Your framework's going to do proxies for you. You're not going to write this kind of stuff. And that's okay, but we've been increasing the surface area of complexity of JavaScript, making more JavaScript and more things to learn and more things to go wrong and more things to be abused. And we've been doing it because JavaScript is being pulled in this other direction to service the use case of the machine instead of the author, of the developer, of the communicator. And we not only added proxy, we've added typed arrays. Again, a very important feature, but none of you are going to write code to discover whether you are on a little endian or big endian system. That's just not a thing anybody on the web is ever going to write code for. So this feature exists in JavaScript, and it has a surface area, and it can be abused by people that are trying to break in and create vulnerabilities to your systems. As a matter of fact, this next one, shared memory and atomics, we now have multithreading capabilities in JavaScript. And I'd like to take credit for that, by the way, because I stood up on a stage for years saying we're never going to have multithreading. And as soon as you say something's never going to happen, it's guaranteed to happen. So you can thank me for that. We now have multithreading. But guess what? This amazing thing where we could now use atomics and shared array memory segments between different threads of JavaScript, that was immediately pounced upon by people trying to create security vulnerabilities. You might remember about a year and a half ago when there was a vulnerability in the CPUs, the Spectre, and all those other bugs. They were exploiting bugs in JavaScript by creating high-resolution timers with shared memory segments. So they had to turn off this feature that they had spent all these years trying to put in, because as soon as you add a feature, somebody's going to try to figure out how to abuse that feature. So there is a real cost to expanding the surface area of a language just to try to serve some particular use case. And it's that question that I don't think we've been asking ourselves as responsibly as we should. And of course, after we got atomics and shared memory and they took this stuff away, well, now you ask, well, we're not even writing our code anymore, right? Because the code that runs in the web is code that's gone through several Babel transpilation steps and Webpack. Babel's great because we can write nice, beautiful code like that, and we can ship really great code like that. Right? That must be better for the web. Now, I'm not down on transpilers. They're certainly an important part. I welcome our new transpiling overlords. This is how we move from trailing to leading in the web. That's a great thing. But it is a shift, a seismic shift in the way that we deal with the web, because the code that is running on the web doesn't look at all like the code that was written anymore. And we're only creating more and more separation, and that's the part that I wonder is going to hurt the future of the web. Now, some people say, well, the solution to this is just source maps. You can still look at the original source code. Yeah, source maps are great. I was actually part of working on this when I worked for Mozilla years ago. The source maps are great, but there are problems. For example, source maps don't work that well with stack traces, especially when they're radically different languages. They don't really work well for watch expressions and other sorts of advanced debugging. And there's a bunch of other little issues with them. So they're not a perfect solution. They're just sort of a temporary stopgap. Then we have other systems like TypeScript and Flow and other languages, basically languages that look like JavaScript, but they've been added other things to it. And I get asked all the time, what do you think about TypeScript? I'm glad that TypeScript exists. I really genuinely am. That for a certain segment of our developer population, I think it makes complete sense to be using TypeScript. It solves problems that I don't have in ways that I don't like, so I don't personally use it. But it's not a bad system. I'm glad that it exists. Except I'm not sure that we're really counting the cost of locking ourselves into a non-standard system. Right now, that doesn't seem like a big cost. But if you look back over the history of technology, every single time you've locked yourselves into a closed system, it has turned out to be not a great decision. So I want us to be asking these questions about the decisions that we make. We get so myopically focused on all I got to do is ship the next delivery of this code, and we don't ask, what is that going to mean for my code base a year from now and 5 years from now? We've talked about adding macros to language. This is a really cool feature. I love metaprogramming. Being able to write a macro that transforms, this is like an old example, transforming the let keyword, so you have stuff like that. And what actually runs in the browser is that. This is like Babel to the whole new degree because it's running inside of the JavaScript engine. On the fly, it's rewriting the code. That's what a macro does. It's going to be even harder to figure out what code's running because it won't even be the code that was shipped to the browser. It'll be code transforming itself in the runtime. There's a real cost involved in those sorts of decisions, and I'm not sure anymore that that's the direction we want to go. Some of you know Tom Dale, real famous. He's one of the lead developers for the Ember framework. Tom Dale wrote this blog post about a year and a half ago called Compilers of the New Frameworks. And he put out this interesting thesis, which was the future of the web is not all these compilers like Babel. The future is that you're going to, all these frameworks like Ember, the future is basically that those frameworks will become your language. That there will be like an Ember language or like a React language, and it will not at all be restricted by what JavaScript it is. It'll evolve on its own timeline with its own feature sets, and those compilers will just write all your code for you. So I got to thinking, well, that's interesting. If the framework authors can experiment with the future of what web programming is about, does that mean that the rest of us can experiment with it? So I had this one idea. I wanted to write curried function declarations, functions that could accept more than one input. And I put this proposal idea out there. I said, this seems like it would work. I've checked the JavaScript grammar. I think that it would be compatible. What do you think? And I got several hundred responses like, that sounds really cool. That'd be great for functional programming. Let's do that. So I put out this message and I said, all right, here's what I'm going to do. I'm going to fork one of the parsers and just put up an experimental parser, and let's play with this and see what it works. And I immediately got all of these thumbs up in the public. People are like, this is great, this is awesome. And then I got dozens of messages from TC39 members in my private message stack saying, my God, no, absolutely not. Under no circumstances should you go fork the parser and come up with your own idea for what JavaScript should be. Because we're too worried that you're so popular. They literally told me this. You're such a high-profile figure that if you come up with an idea that's not compatible with what we want, now we'll have a division in JavaScript. Don't make a parser that does stuff that's non-standard JavaScript. So my takeaway from this is it's okay if you work for Microsoft or you work for one of the famous frameworks. It's okay for you to experiment, but us, we don't get the right to participate. And to me, that doesn't sound like the open collaborative systems that have always won. We're creating a future where only the few get to decide what's going to happen for the future of our platform. That is not a healthy direction to move. ASM.js was a great step along the way. We got ASM.js to be able to do faster, more performant JavaScript, and of course the next step was WebAssembly. Now I get asked all the time, what about WebAssembly? What do you think about WebAssembly? Well, I'm glad that WebAssembly exists. It represents a really important answer, almost a pressure release valve. There are things that people want to do in the web platform that don't make sense to put into JavaScript. So let's give them some other way to do it from another language and target the web platform for their delivery. That makes complete sense, and I'm hugely in favor of that. But the one question that I want to ask is, because this is what WebAssembly looks like compiled, and it doesn't even remotely look like the kind of code most of us could read and understand. So we're creating an even further gap in separation. And this story of all these things that we keep doing in the machine side of the equation are all because we have real valid questions and real valid use cases to solve, but the solutions that we're coming up with, we come back to this one question: what is that going to mean for the future view source of the web? Now, I've said this many times, and I've been made fun of by some of the popular kids in the JavaScript community because they make fun of this quaint idea that you could do a view source and understand what the web is about. There's like, oh, that's silly and stupid. That's what we did back in 2000. Well, I have news for you. The web exists because people did that. The web would not have survived if people couldn't figure out how to learn the web. And what I'm worried about for the future is that some new aspiring developer, right now he's like 10 or 11, he's interested in the web, and a couple of years from now when he goes to do a view source of the web, instead of seeing some HTML and CSS and JavaScript and being able to copy and paste a mouse cursor, now he's going to have some Go and some Rust and some PHP and some JavaScript and half a dozen other languages that are all mixed together in a completely nonsensical way. And that's going to be, we're going to say that's the best future for the web because it's so much more performant, it can do all of these other things, and we're going to forget that people need to be able to onboard to the web. People need to be able to learn and understand and debug the web. So are those futures that we're painting with machine JavaScript really the future that we want to get? Is it worth the cost? I don't have the answer for that question, but I don't think that question is being asked. For a long time, the alternate title for this talk, by the way, was A Tale of Two JavaScripts. For a long time, the Tale of Two JavaScripts has been a good, nice fairy tale with a good, happy ending. And so far, it's been a very good bet. But I want to ask, where are you placing your bet for the future? Are you placing your bet on the divergence of these technologies that makes it harder for us to come together and collaborate? Or are you placing your bet on ways that makes it easier for us to collaborate? Because the open collaboration is the thing that has always won. And if we give that up far too easily because we want the new hot plugin in Babel or whatever that decision is, then we may not be creating that future that we want. We may look back 10 or 20 years ago with nostalgia. Remember when the web worked? Remember when people could learn and onboard to the web? I don't want that future, so I want you to begin asking these questions as you make the technology decisions within your own companies. Again, I don't have those answers. I'm not trying to tell you you're wrong, but I don't think you're asking those questions enough. I don't think you're dealing with that particular responsibility to the weight that it has. Thanks very much for listening to these thoughts.